myself Abdul Wajid Bhatt from the Department of Medical Radiology and Imaging Technology at GNA University, Phagwada, Punjab. It gives me immense pleasure to welcome you all to today's session, which is on quality assurance and quality control in digital radiography. In this session, we will explore how a planned quality assurance and quality control testing will ensure that digital radiography system delivers a safe, accurate and consistent results. By the end of this presentation, you will have a clear understanding of that what is the difference between quality assurance and quality control. Also, you will understand that how various tests and how various checks are performed in digital radiography. And next thing is you will understand that how these practices improve both patient safety and image quality. So let us begin our discussion on the quality control and quality assurance in digital radiography. So these are the contents which we have to discuss in this presentation. That is, the introduction is there, quality control is there, quality assurance is there, and first test which we perform in the digital radiography, that is the visual inspection of equipments. And the next one is the detector calibration checking, offset and flat field. And the next content is related to another test, that is system warm up. And the next one is the image quality checking, phantom test. And the next test is monitor cleanness and functioning. And the last one is the PACS network connectivity in radiology quality control. So first, we will discuss regarding the quality assurance. What basically quality assurance is? Simply, we can call a planned program to keep the whole radiography system correct and consistent, that it is correctly working and it is producing a high quality radiograph. And another thing, in the another way we can define it, that is a planned program that makes sure that the whole radiography system, it will include the equipments, it will include the staff, it will include the various methods, give safe, accurate results. And next is, what is then quality control? Quality control is the actual tests and checks done on the X-ray machine and images to see if they are working properly. These are the tests to see that if my X-ray equipment is working properly, if it is producing a high quality image or not. To go through these tests, we call it as a quality control. And what is the main goal of this quality control and quality assurance? The main goal is to ensure that the X-ray equipment is producing a constant, high quality diagnostic image. And by this thing, we can maintain a high accuracy of diagnosis. And another goal is to minimize the radiation dose to the patient and staff, but maintaining a high quality standards of the image. And the another goal is it ensures the safety, reliability with international performance standards. That is the ensure what guidelines are being provided by the Atomic Energy Regulatory Board, Baba Atomic Research Center, AERB. We should align with those guidelines and regulations. And simply we can call now that the quality assurance, that is the overall planning of the system to check whether it is working properly or not. And quality control is that specific tests or specific actions which we perform upon the equipment to check, to maintain a proper high quality standards of the image. And next is one is this is the visual inspection of equipment, and this is the first test which we perform in the digital radiography. And how this test is performed in this digital radiography, first thing is that we have to check the power supply and cables. We have to check, we have to look for any loose connection in the cables, we have to check any damage in the wires, we have to check any exposed insulation in the wires. And next is inspect x-ray equipment and housing, that is to check any crack in the housing, to check any oil leakage from the X-ray tube, to check any overheating side of the X-ray tube. We have to check all those things. And next step is that is examine quality control panel. That is examine control panel. What is it? Examine control panel. That is a control panel is a system by which we can control the machine, by which we can set KVP, by which we can set MAS, simply we can call by which we can operate the machine. We can on the machine, we can off the machine. So we have to check it that if KVP button, KVG switch is properly working, MAS switch is properly working, on off button is properly working. So we have to check all the meters. Voltmeter is there, we have to check voltmeter properly, we have to check ammeter properly, and we have to also check various warning lights. Several warning lights are present upon the control panel. Overload is there, exposure is there. We have to check those lights that are they working properly or not. And next step is that is we have to check the collimator and light field. Collimator is a device which helps us to shape the X-ray beam properly, and we have to make sure that are the shutters of the collimator working properly or not, are they moving smoothly or not, and the light and the line alignment which helps us in proper centering of the equipment, proper centering of the patient. We have to check it that is it aligned in the center, is it aligned properly, or is it deviated. We have to check. This is also the part of the visual inspection of the equipment. And next one is that is we have to inspect the mechanical parts. We have to inspect various mechanical parts, just like a patient table is there, we call it as a patient table, and we have to check patient table that is it moving properly, front and back, is it tilting properly. We have to check this also. We have to check the stands, that is the stands of the X-ray tube, arms of the X-ray tube, and lock for stability, that is it working properly, locks are working properly or not. And smooth movement, we have to check the movement of the X-ray tube also, that is it moving properly or not. That is also the part of the visual inspection. And another one is that is check safety devices. We have to check various safety devices. We have to verify the emergency switch, that if the emergency stop button is working properly or not. Various warning signs are there, and we have to check that when we on the machine, a bulb is there which is positioned outside the room. We have to check when we on the machine, when we start exposure, is that bulb glowing or not. That is also the warning sign that exposure is going on inside the room. And next is that is we have to check the protective barriers are intact. We have to check the walls that protective barriers are intact or not. If there is any damage in those protective barriers, that is the lead sheets, any crack is there, any other damage is there in the walls, we have to verify it. And next is that is we have to check the accessory check. Accessory check is look for damage in the grid. A grid is adjusted, that is adjusted below the table. We have to check that is it aligned properly, is it fixed with the table properly. We have to physically examine the cassette also, that is there any crack in the cassette, is there any problem in the case. If there any lock problem in the case, we have to inspect that thing also, and we have to check detectors, that detectors are connected with the system properly, they are attached below the table properly. And also we have to inspect the lead aprons, that if any crack is there, any hole is there in the lead apron, we have to note down it also. And final step is, if we detect any problem in any one of these visual inspections, if we report any problem, we have to report it immediately to the service engineer, we have to immediately report it to biomedical engineer. And we should always avoid not using the faulty equipments, because faulty equipments are dangerous for the patient. Stop also, because sometimes they can cause a high exposure to the patient. Sometimes they can cause an electric shock to the patient. So we should always avoid using the faulty equipments. And the next thing is, that is the next test which we perform in the machine, that is the detector calibration check, offset and flat field. This is the another test which we perform upon the detectors. And this is a quality control test. This quality control test is done to make sure that the digital detectors produce uniform image without any artifact, without any distortion, without any bright spot, without any dark spot. And we are having two types of detector calibration checks. First one is offset calibration, and another name for offset calibration is, that is the dark image test. That is the dark image test. And how this test is performed? Done without any X-ray exposure. This test is done without any X-ray exposure. That means we didn't have to expose the detectors, but we have to on the detectors, we have to on the machine. And always there is a, we call it as an electronic noise, or we call it as a some sort of signal is there, which is produced by the detectors. So detectors record that signal and will produce a black image to measure background electronic noise. So when we we didn't have to expose in it. So when we record that signal, which is automatically produced by the a small signal, a minute signal, which is produced by the detectors, we will record that signal, and after that, that signal will produce an image upon the display, and that image will be a black image. But that image is due to a background noise, due to electronic noise of the detectors. And after that, this noise is then subtracted from actual image to avoid any false signal. When we will go for a patient, we will examine the patient. At that time, we will subtract this black image from the actual patient image, so that we can get a image without any background noise, without any, we can call, detector noise. And simple example for this test is, just like we are having a clear A4 size paper without any dot, without any lines, and we will go for scanning of that paper, plain paper. When we will place it upon the scanner, and we will get a scan of this page, A4 size page, but no line should be there, no dots should be there. But when we place it upon the we can call a scanner, and after that, when we get it back, and small dots are there, small black color dots are there, and sometimes there can be small lines are there, and those lines are due to the background defect in the scanner, background defect in the printer. And same thing, this is known as offset calibration. After that, if we will go for another scan, any documentation scan, we can subtract the first scan. We can subtract those dots and those lines which are already present in the background of that printer, in the background of that scanner, and we can get a high quality scan without any dots, without any lines. And same thing is done in the offset calibration, that we can get a image. When we minus this, we can call a dark image from the actual image of the patient, we can get a image without any background noise, without any electronic noise, and that image will be of high quality and high accuracy. Next is, that is the flat field calibration, and another name for this one is, that is image test. This is also known as flood image test. And what is this flood image test? And this is done by exposing the detectors with a uniform X-ray beam, with a uniform X-ray exposure, and the KVP should be 60 to 70, and the MAS should be 8 to 10. And after that we have to expose these detectors. When we expose these detectors, and after that we can get a image, ensure that final image looks uniform. If it looks uniform, then we can get a detailed image of our detectors, that our detectors are working properly. They don't have any variation in the pixel sensitivity. They are high sensitivity to radiations. They are detecting the radiations properly. But if this image is without any, we can call dark spot, without any bright spot, then we can call our detectors are working properly. Our detectors are without any, we can call any problem, without any defect. So by this thing we can also get a high quality image. And this is a test, another test which we perform in the detectors to check any non-uniformity in image prediction. And another thing is, that is how this detector calibration test is performed in the machine. Now prepare the system and select the calibration mode, that is for dark image, or we can call for offset calibration or flat field calibration. We have to check that which mode we want to run. Accordingly we can run that mode, and system processes the data. When we expose the flat field calibration and offset dark calibration is done without exposure, and all the data is processed in the system and stored correctly. After that verify taking a test image. When these calibrations are done, that means any issue which is noted is resolved now, and we have to verify it once again. Take a test image and it should look even and free of any artifact. If that test image is free of any artifact and is even and is uniform from one corner to another corner, then that problem is resolved in the detectors. And the next test is which we perform on daily basis in the machine, that is system warm up. In digital radiography systems, in DR systems, and in X-ray systems, it can be a CR system, it can be a mammography system. A warm up procedure is recommended before routine use. That is, it is necessary to go for a warm up, and it usually means running the machine. What is the warm up? Simply we can call running the machine through a series of low exposures, before full operation. Before full operation, we have to run a machine through a series of low exposures, and by performing this test, by performing this system warm up, it will help us to stabilize the X-ray tube and detectors. To stabilize the X-ray tube and detectors, prevent sun damage from high exposure on a cold tube, and also it will ensure constant image quality and reliable performance. And another thing is, it will also increase the life of the X-ray tube. It will also increase the life of the X-ray tube by reducing the risk of any crack to the detector, any crack to the any crack to the detector, any crack to the cathode, any crack to the anode. And the next test which we perform on daily basis is, that is image quality check. And we also call it with a name, that is a phantom test. And what is this phantom test? A phantom, simply we can call it, is a spatial object. It is a spatial object which is which acts same like as the human tissue, Simply we can call that it mimic human tissue, and it has several patterns, just like it is displayed here, that this is a phantom and it has several patterns. Lines are there, holes are there, and various steps are there, and these things help us to recognize that is my resolution maintained properly, is my contrast properly, is uniformity maintained properly in the image. We can check it with the help of this phantom, and by imaging the phantom we can judge if the system is producing diagnostically acceptable image with a high accuracy, with a high quality. And in digital radiography systems, and first is that is the setup, place the phantom. That means we have to place the phantom on the flat panel detector. Flat panel detector, this is the sensor, this is the sensor system of the DR system. We have to place it upon the sensor, and this sensor, upon the sensor, next step is that is expose. To expose, use a recommended factor, that is the KVP and MAS. That is KVP, it should be 60 to 70, and MAS should be 10 to 15. After that, we have to expose this phantom. When we expose this phantom, the detector immediately sends this information, or we can call captures the image, and the image will be displayed upon the monitor, or we can call image will be displayed upon our workstation. And what we have to evaluate in that image, we have to check, and we have to check the spatter resolution. That is, the fine line patterns must be clearly visible. These fine lines must be clearly visible with a proper distance and contrast resolution. That is, low contrast objects, holes, and we can call steps should appear distinct with a proper distance, with a proper structure. Then any defective pixel, any reduction in the grayscale, any grid lines which will appear upon the image, any noise or any distortion, or simply we can call any problem in the image, that is known as the artifact. Any distortion in the image, we have to check for it, and we have to check for the uniformity. That is uniformity maintained entire image or not. The image should be without any bright spot, it should be without any dark spot. Then we can call that our machine is working properly, it is producing an image of high quality. And in DR system, it is clear to you all that in the DR system, image appears very instantly. It appears very instantly on the screen for evaluation, and for the CR system, it will take time, that we have to take the IP plate to the reader, place it inside the reader, and after that reader will read it, and after that data will be converted into analog signal, and analog to after that digital signal, and digital signal after that it will be displayed upon the monitor. But in CR, it is instant, it will directly appear upon the monitor, or we can call computer system of the machine. And the next, that is monitor cleanness and functions. Monitor cleanness and functions, and this is a test which we also perform on daily basis upon the machine. Check the display screen for dust or fingerprints. We have to check the screen, we have to check the monitor by which we can call operating the machine. We have to check it, and we have to check that if there is any dust is there, any fingerprints are there, so we have to clean it with a, we can call a soft lint free cloth, or we have to clean it with a various approved cleaning solutions. And if any dirty screen can reduce image brightness, it can reduce the image brightness, it can reduce the contrast, and which can lead to misdiagnosis also, which can lead to misdiagnosis, or we can call which can lead to poor diagnosis. And what monitor functions we have to check? Ensure the monitor displays image with correct brightness. We have to check it, we have to ensure it that it displays the image with a correct brightness, with a correct contrast, with a proper resolution. And after that, we have to display a test, and we call it a use a test pattern, that is SMPTE or TG18 QC pattern, for to check for any distortion, to check any uniformity. What is this test pattern SMPTE? Simply, this is a spatial image, which is a spatial image with different grayscales, with different structures, holes are there, lines are there, and different patterns are there, and we will display this image upon the display of the monitor, and it will help us to recognize that is my display displaying the image properly with proper colors, with proper structures or not. So this is a special type of image, SMPT and TG18 QC pattern. These are the special types of image by which we can check that if the contrast is maintained proper, if the brightness is maintained proper, and the monitor is working properly, it is displaying the image properly upon the display of the machine. And distortion is, that is the straight lines should appear straight. Any distortion, we have to check any distortion, that is the straight lines, any straight anatomical part should appear straight upon the image. Uniform brightness across the screen, that from one corner to another corner a uniform brightness is maintained in the screen. And ability to see fine details, small we can call small anatomical parts with a low contrast, it should appear upon the screen also. And next thing is, that is the monitor cleanness, ensures a clean screen. And what is monitor cleanness? Simply now, it is ensures a clean screen. And monitor function, that is ensures accurate display of diagnostic images. It will ensure us that all the diagnostic images appear upon the display with a high quality, with the accuracy, so that our diagnosis can be good, our diagnosis can be accurate. And next thing is, that is related to PACS, and this is a network connectivity in the radiology. We call it as a picture archiving and communication system, and this is a network connectivity in the radiology, and it is a system used to store, retrieve and share medical images. It is used in the X-ray system, it is used in the CT, it is used in the MRI also, and ensure images can be sent from the X-ray CRDR system to workstation and radiologists. We have to ensure it that images are sent from the X-ray system, CR system, DR system to workstation and radiologist for we can call for diagnostic purpose, for checking purpose. And next is network connectivity checking. We have to check the network connectivity, that we have to verify it that our imaging system is connected to the hospital network properly. That is the RIS is there, Radiology Information Center is there, HIS is there, that is Hospital Information Center is there. We have to check it that our imaging system is connected with these systems properly in order to store, in order to retrieve the data, medical imaging data. And next thing is confirm that images are transferred. Confirm that images are transferred from one system to another system with a proper name, proper ID, exam type are correctly linked with the image. That means all things should be linked with the image properly, that this is the image of this patient and this patient is having a patient ID this, and the examination type is, it is the chest, it is the abdomen, or it is any other thing. So it should be linked with the same patient, and ensure that radiologists, we have to ensure it that radiologists can open this image, view this image and report image remotely if needed. So if our PACS system is working properly, our network connectivity is proper, then the radiologist can report our image remotely also. And simply, what is now PACS? It is a storage and sharing of medical image. Storage, by this in the PACS we can store our data, and we can share the data with the help of this picture archiving communication system. And network connectivity, make sure image moves smoothly from X-ray system to PACS and from PACS to workstation without any error. We have to check this also. These are the tests which we perform on daily basis upon the DR system. So that was all for today from my side. Thank you for your patience and time. Have a nice day. Thank you.